Why are filter capacitors crucial for stable DC power supplies? Imagine trying to listen to your favorite song but there's constant static noise. That static is like the ripple in a power supply. It can make your electronic devices behave unpredictably. When you convert alternating current to direct current using a rectifier, you get a pulsating voltage. This pulsating voltage isn't smooth. It has ripples that can cause problems. Without fixing these ripples, circuits can malfunction, produce noise, or even get damaged over time. This is where filter capacitors come into play. They are placed right after the rectifier in a power supply. Their main job is to smooth out those voltage ripples. When the rectifier's output voltage goes up, the capacitor charges and stores energy. When the voltage drops, the capacitor releases that stored energy back into the circuit. This charge and discharge cycle acts like a buffer, filling in the gaps between the pulses. It reduces the size of the ripples, making the voltage more steady. The size of the capacitor matters a lot. Larger capacitors can store more energy, which means they can smooth out bigger ripples. In circuits powered by the standard mains electricity, which oscillates at 50 or 60 times a second, electrolytic capacitors with high capacitance are common. In high-frequency circuits, like switch-mode power supplies, capacitors need to respond quickly to rapid changes. So, their ability to react fast becomes more important than just their size. Filter capacitors also help reduce electrical noise. Any spikes or interference from the power line can be diverted to ground by the capacitor. This makes the power supply cleaner, which is especially important in analog electronics. Small amounts of noise can distort signals or cause unwanted hum in audio equipment. Without these capacitors, the voltage supplied to your circuits would be unstable. This instability can cause devices to reset unexpectedly or give inaccurate readings. For example, in embedded systems, microcontrollers might reset or behave erratically if the power isn't steady. In audio gear, ripple can cause a humming sound or distortion. Choosing the right capacitor involves considering the ripple frequency, maximum voltage, and operating environment. It's important to pick capacitors rated 4 voltages higher than the peak output to prevent failure. Also, the capacitor's equivalent series, resistance, and ripple current handling capacity are key factors, especially in high-power applications. In simple terms, filter capacitors are the unsung heroes of stable power supplies. They smooth out the voltage, cut down noise, and ensure your electronic devices run smoothly. Proper selection and placement of these capacitors are vital for reliable, long-lasting electronics.